In this video, we'll demonstrate how to troubleshoot a recurring milk spoilage problem affecting the storage tanks in our dairy plant. In a dairy processing facility, raw milk is delivered daily and stored in large insulated tanks. To prevent spoilage, each tank is equipped with a chiller system. This system is responsible for maintaining the milk at a temperature below 4 degrees Celsius. Now, this low temperature is critical. It slows down bacterial growth and preserves milk quality until it's ready for pasteurization and packaging. For the past 3 nights, we have faced a recurring issue. Milk stored in our tanks is spoiling overnight. Each morning, we discover that the product quality has dropped, leading to losses and concerns about our process reliability. During the day, our chiller system operates as expected, keeping the milk below 4 degrees Celsius. But the spoilage only occurs overnight, making it difficult to pinpoint the root cause through manual checks alone. Like many modern factories, we rely on OPC UA, a secure, standardized protocol to collect and share real time data from our process equipment. OPC UA connects our sensors, PLCs, and chillers to a central system, making it possible to monitor and analyze operational data. This is where OPC UA Explorer comes in. With this user friendly tool, you can browse all available nodes in your industrial system, read and write values, and easily access historical data. You can also monitor nodes in real time with synchronized logging and plotting, making it simple to visualize trends, detect anomalies, and troubleshoot problems right from your desktop. To get started, launch OPC UA Explorer from the app gallery. You will find it under the Test and Measurement section. Next, click on Add Server. You can begin by scanning for all available OPC UA servers on the server URL and selecting the correct server from the drop down menu. The security policy is set automatically to the highest available standard. For this demonstration, we'll use the recommended default settings. Once the server settings are configured, we'll proceed to the connection. To connect to the server, click Connect from the toolstrip, enter your credentials, and authenticate. Once connected, the address space panel will display all accessible nodes on the OPC US server for further exploration. Let's browse the address space to locate the relevant nodes. In our case, tank to temperature. When you select a node, the node information panel updates to display its metadata. Here, we can see that we have read access for this node. Let's go ahead and read the current value. It shows that the temperature is below 4 degrees Celsius, which is in the optimal range. To understand what's happening, we'll need to review last night's temperature values along with the cooling system's performance. Now, to retrieve historical data, start by selecting the relevant nodes. Then, navigate to the Read tab in the Node function panel and choose the historical value option. Specify your desired date and time range and click Read. Since we have requested a large amount of information, it may take a moment to load. Once the data appears, you will notice there's quite a lot to review. You can expand the panel for a better view. Now that's a lot of data to handle manually, but we can clearly see that there are instances where the temperature exceeds 4 degrees Celsius. To analyze this further, we'll export all the data to MATLAB. We'll find the data as a workspace variable. Now to remove any poor quality samples, we'll apply a data filter and then plot the filtered temperature values over time. The analysis shows that the chiller status switches to false at around 2:30 am, and this is immediately followed by a rise in milk temperature. At about 3:30, the chiller status returns to true and the temperature drops back to the normal level. To look for any patterns, we'll repeat this process for the past 3 days. Reviewing the data, we can see that 3 nights ago, the chiller system maintained the temperature as expected throughout the night. However, over the past 3 days, the chiller has been malfunctioning during the night. causing temperatures to rise and resulting in milk spoilage. These findings confirm that the temperature increase is caused by chiller failure during the nighttime hours. To fix this, select the backup chiller status node, check its current state, and then write a value of true to activate the backup unit. The audit log confirms that the command was executed successfully. To validate the corrective action, we'll simulate the fault scenario by turning off the chiller and then monitor the temperature of the storage tank. To monitor the temperature node, add the node to the monitoring table, switch to the plot tab, and observe the data in real time. We can see that the plot remains stable, confirming that the temperature is now under control. So using OPC UA Explorer, we were able to identify the issue, confirm the root cause using historical data, and implement an effective solution all within a single platform. To take your operations even further, OPC UA Explorer lets you generate MATLAB code with just one click. This ready to use script leverages the Industrial Communication Toolbox APIs, making it easy to automate server connections and monitor nodes directly from MATLAB. Thank you for following along. To learn more about OPC UA Explorer, check out the links provided in the description below.